Question from communication system. The frequency response HF of a linear time invariant system has magnitude as shown in figure. Magnitude response is shown. And there are two statements given. You have to identify out of these two statements which one of them is correct and which one of them is incorrect. So only one option is going to be correct in this case. Let us see this. What are the two statements and accordingly the answer. Now the first statement is the system is necessarily a pure delay system for inputs which are band limited to minus alpha to plus alpha. That means if the input is within this band minus alpha to alpha, the system is necessarily a pure delay system. So there is no frequency, the phase response is not given, the frequency response is, the magnitude response is given. Okay. A pure delay system, if I consider a LTI system, okay, so pure delay system is yt is equal to x of t minus t naught. The frequency response of this, if I convert this into frequency domain, I'll get y of j omega x of j omega e to the power minus j omega t naught. So I can write h of j omega x1 e to the power minus j omega t naught. Okay. So the phase is linear function of frequency and the magnitude is 1, right? So magnitude is 1 here, right? So since only magnitude response is given, we can say that it can be necessarily a pure delay system. Since phase response is not given, we cannot comment, right? So we will assume that it can be within this minus alpha to alpha. This will give me a pure delay system. So ambiguity arises because the phase response is not given. And the phase response, if we assume that phase response is a linear phase response, then definitely it's going to be a pure delay system. So it's just saying necessary. It is not that must, right? It must be a pure delay system. No, system is necessarily because with the given information, you can conclude that. So statement 1 appear to be correct. Now coming to the second statement, for any Whitesnake stationary run input process with pass field density Sx of f, the output pass field density Sy of f obeys this. Yes. For second statement, if I have the same input and random input and output, the pass field density of the output Sy of f is going to be h of f magnitude square into Sx of f. Now Sx of f is given minus alpha to alpha, h of f is given as 1, so magnitude wise it will become 1 square is 1. I can write this as Sy of f is equal to Sx of f, right? So within this minus alpha to alpha, this condition will follow. The second statement is also correct. Okay, so answer for this is option A. Statement 1 and statement 2, both are correct. There is certain ambiguity in statement 1. If that ambiguity would have been not there, that means if someone consider this, let's say pure delay, or let's say that phase response is given, so we cannot conclude, in that case, option C will be the right answer. Okay, so there is a confusion between A and C, but as far as I feel, since it is not must, it is necessarily, okay, it could be this thing, so certain degree of advantage we can take here and we can say that statement 1 is correct. That's the end of question from communication system. Question from communication system. This question is from the information theory part of it. Let us see the solution of this. Let Hx denote the entropy of a discrete random variable x, taking k possible distinct real values. We have the following statement is are necessarily true in that case. Okay. So let us say that x is taking values x1, x2, xt. Okay, each is having some probability p1, p2, pk, right? So the probability distribution is. So we have the entropy of random variable x, entropy present in random variable x, that is h of x. Okay, so that is one part which is given in the question. Now, what is happening? The first statement is whether we have to see whether this, how many of these are true, because multiple options can also be true. Now, the first case, hx is lesser than or equal to log 2 of k. Now, this is a property of the entropy, that the maximum value of entropy is nothing but log 2 of k, where ak is nothing but the number of possible distinct real values. Assume that if p1, p2, let's say option A, if p1 is equal to p2 is equal to pk is equal to 1 over k, all are equally distributed with equal probability, then h of x is going to be 1 over k log 2 of 1 over 1 by k into k. Okay? Like this, k values will be there, and if you solve this, you will get nothing but log 2. Okay, this is the maximum entropy present. So this statement is correct. Okay, other entropies, if they are not equally distributed, it will be lesser than. So that is statement which is correct. Now coming to option B. Option B is a linear transformation of x to 2x. So here I have a random variable y, which is nothing but equal to 2x. So what this y will become? Y will take nothing but 2x1, 2x2, 2xk. But still the value of 2x1, the probability of 2x1 is will remain p1, value of this will remain p2, value of this will remain pk. Right? Probabilities will not change. So here in this case, entropy of y will be same as this, or I can write the equation less than equal to h of 2x holds here also. Okay. Because if you see the entropy, it does not depend on what the values x is taking, it depends on the probability. Okay, if the probabilities are not changing, so entropy will also follow this condition. So this statement is also correct. Now coming to the non-linear transformation. Non-linear transformation is, I will say that y is equal to x square. Okay, now here what will happen is, just see. Assume that x is taking the values like this: -2, -1, 0, 1, 2. Now what y will take? Y will take value 4, 1, 0, 1, and 4. Now this 4 is coming 2 times, so the probabilities will change, because here the number of values are 5. Here the number of distinct real values are only 3, because this is same as. So the number of distinct real values have changed. Once the number of distinct real values have changed, the probabilities will change. Once the probabilities will change, this condition will not hold good. This can be more than this. Okay. So option C is not the right answer. Okay. H of x square can be lesser than h of x. So it will happen in this case. Now coming to h of x equal to h2 of x. So this appears to be like a non-linear, but you just see. If I take x distinct possible real values, then 2 to the power x will also give me the distinct possible values. Okay. Now again, since all the values will remain, only k values will remain, all will have probabilities p1, p2 to pk. So h of x will become again same as less than equal to h of 2 to the power x. This condition will also hold good, just because the number of values in 2 to the power x are all distinct. So that is a condition. So we need to understand here, if there is a nonlinear transformation and if the number of possible distinct real values are changing, then the entropy will be lesser. Okay, such in this case, if you see, the entropy will be lesser. The correct answer for this is A, B, and D. That's the end of question from communication system information theory part. Question from communication system. This is from finding the bit rate. A symbol stream containing alternate QPSK and 16 QAM symbols. If symbols from this stream are transmitted at a rate of 1 mega symbols per second, the raw uncoded data rate is dash megabits per second. We have to find out this. Now, what is happening here is there is a symbol is getting transmitted alternately. So I can write here symbol of QPSK followed by symbol of 16 QA followed by symbol of QPSK followed by symbol of 16 QA. Likewise, it goes on. Okay. This will keep on transmitting alternately. So QPSK, one symbol of this, we have 2 bits per symbol here, and we have 4 bits per symbol here. Then again 2 bits per symbol, 4 bits per symbol. Okay, like this here. Now, if I convert this into data rate, so this is going, if I multiply this 1 mega symbol per second, I'll get this as 2 Mbps. This is 4 Mbps. 2 Mbps, 4 Mbps. If I take this as a one group, then what is happening here? I'm transmitting 6 megabits per 2 seconds. 1 second for this, 1 second for this, right? So what is the data rate here? It's going to be 3 Mbps. So the overall data rate in this case is on for data going to be 3 megabits per second. So just 2 megabits are getting transmitted per second here, 4 megabits are transmitting per second here. So within 2 seconds, there are 6 megabits are getting transmitted. So the data rate is going to be 6 megabits per 2 seconds, that is 3 megabits per second. Answer is 3 megabits per second for this question. That's the end of question from communication system. Question from communication system from the analog communication portion, which is related to pre-emphasis and de-emphasis filter, okay, that we use in the FM broadcast. Now, what is asked here is the pre-emphasis filter response is given. We have to find out the de-emphasis filter response, filter component values, okay, based on this pre-emphasis. Okay, so let us see that. Now, one thing that we need to understand is the pre-emphasis and de-emphasis are just like kind of equalization. Okay, not exactly the equalization, but the response is here that H P of omega magnitude is inverse of H D, which is de-emphasis of omega magnitude. Okay, so what is the magnitude of this? This is going to be root of 1 plus omega by omega naught whole square equal to 1 upon H d of omega. Right. Now let us find out the H d of omega. Given RC filter, H d of omega is equal to 1 over 1 plus j omega RC. If I take the magnitude of this, it is going to be H d of omega magnitude is 1 over root of 1 plus omega square R square C square. Substituting this over here, okay, we will get root of 1 plus omega by omega naught whole square is equal to, and you take this, it will become 1 plus omega square R square C square. Okay, now I can compare and can see that 1 upon omega naught is nothing but RC, right? What is omega naught given as 10 raised to power 4? This implies RC must be equal to 10 raised to power minus 4. Now we have to choose that option which will give RC equal to 10 raised to power. Multiple options can be correct. Okay, so let's just be careful in this. So if I see at 1 kilo ohm and 0.1, so that is going to become 10 raised to power minus 4. If I look at this 1 kilo ohm and 2 microfarad, that will become 2 into 10 raised to power minus 3. And if I look at this, this is also 2 into 10 raised to power minus 3. And if I look at this 0.1, this is 1 into 10 raised to power minus 3. So option A is the correct option. Reading all will be not the value which is desired. Okay, so the value of R must be 1 kilo ohm, value of C must be 0.197. So the concept here is This we should know this. Okay, that's the end of question for communication system and log questions. Question from communication system, from the information theory part where we find the channel capacity. Now there's a transition diagram given, and you can say that this part is a source and this part is the destination. The source X is taking the three values A, B, and C, and Y, the receiver is taking the three values A, B, and C, and there is a transition probability given for each. Okay. Now, if there's some kind of symmetry exists in this transition diagram, we will make use of this to determine the values. Now, what is required in this? A transition diagram of a discrete memoryless channel with three input symbols and three output symbols shown in figure. The transition probabilities are as marked. Okay, alpha and beta. The value of alpha for which the capacity of the channel is maximized. It is given that the parameter alpha lies between 0.25 to 1. Okay, so if alpha becomes, suppose if the parameter alpha lies between 0 and 1, definitely I can say 0 is the value, because if it's 0 then 1 and everywhere it will be like. But if someone asks me that if you can tell the answer just by seeing at this block diagram, then my answer would be 1. Because these are the extreme values where the probabilities will 0 or 1, where the what do you say, the maximum or the minimum are like this. Okay, both 0 and 1 it is same values, right? Somewhere between at 1 by 2 it is going to become the minimum values. So we will conclude, we'll solve and we'll conclude that y alpha equal to 1 is the value for which the channel capacity is maximized. So let us see this. Well, let us define what is the channel capacity and let us try to solve this. Now channel capacity C is nothing but maximizing the mutual information. Okay. Now the mutual information is I x y over the distribution of the x. How it is defined is that mutual information I x y is h of x minus h of x given by, or h of y minus h of y given by. So we will make use of this. So we can use this also, but I'll make use, my choice is this. Now when this is going to be maximum? This is going to be maximum when this is maximum and this is minimum. Right? So when h of x is going to maximum, h of x is going to maximum when all A, B, and C are equal probability. Okay, that means 1 by 3, 1 by 3, 1 by 3. So h of x max value is log 2 of 3. Okay. When probability of x equal to A is same as probability of x equal to B is same as probability of x equal to C. Right. So that is one part. Right. Now coming to h of x given by. H of x given by. What it is? It is probability of y equal to A, h of x given y equal to A, plus probability of y equal to B, h of x given y equal to B, plus probability of y equal to C, h of x given y equal to C. By symmetry, you will find that this, and this are going to be same. Okay. So let us find out what. H of x given y equal to A. It is probability of x equal to A given y equal to A log 2 of 1 over probability of x equal to A given y plus probability of x equal to B given y equal to A log 2 of 1 over probability of x equal to b given y equal to, plus probability of x equal to c given y equal to a log 2 of 1 over probability of x equal to c given y. Okay. Let us find out the individual probabilities and substitute in this, and let's see what is the value of this. Is the conditional entropy. Okay, the information contained in x after knowing y. That's what this denotes. So let us see this. So let us find out this. Probability of x equal to a given y equal to a is nothing but probability of y equal to a given x equal to a. Probability of x equal to a, probability of y equal to a. This is given as 1 minus alpha. This is 1 by 3. And probability of y equal to a is 1 by 3 into 1 minus alpha plus 1 by 3 into alpha. That will become, this value is 1 minus alpha. Right? Now we can see clearly probability of x equal to b given y equal to a. When y equal to a received, definitely x equal to b is not transmitted. So this probability is going to be 0. This is 1 minus alpha. Now coming to this, the last one, probability of x equal to c given y equal to a. If you solve this in the same way, probability of x equal to c given y equal to a is probability of y equal to a, x equal to c, probability of x equal to c divided by probability of y equal to a. Now you substitute this is going to be alpha, this is 1 by 3, this is also 1 by 3, so this is going to be alpha. This is alpha. So I have h of x given y. I can write this as h of x given y equal to a is going to be 1 minus alpha log 2 of 1 upon 1 minus alpha plus alpha log 2 of 1 upon alpha. Okay, so if you see this, when this is going to become 0? This is going to become 0 if alpha equal to 0 or alpha equal to 1. So if alpha equal to 1, this whole term is going to become 0. And once this is 0, so this term will become 0. So this will become the maximum. This is minimum value of this can be 0 only. So the value of alpha is 1, for which the channel capacity is going to be maximum. Okay, so we need not to solve the other things, right? If we want to find the channel capacity, that is one part. But if we do not want to find the channel capacity maximum of this is log 2 of 3. Then we need not to solve it. Okay. For value of alpha, it will be log 2 of 3. Otherwise, it will come in terms of alpha only. That's the end of question from communication system. Question from communication system. Here we have to find out the probability of correct reception. Okay, the probability that the transmitted code word is decoded correctly. So the transmitted code word will be decoded correctly if there is at most 1 bit error. If there is a 2-bit error, then the error will happen. So we have to find out the probability of at most 1 bit error. That is going to give the probability that the transmitted code word is decoded. Why? Because in this question, there is a Hamming code is being used, and Hamming code can correct up to 1 bit error. Consider a communication over a memoryless binary symmetric channel using a 7-4 Hamming code. Each transmitted bit is received correctly and with probability 1 minus epsilon and flipped with probability epsilon. For each code word transmission, the receiver performs minimum Hamming distance code decoding and correctly decode the message bits if and only if the channel introduces at most 1 bit error. So for epsilon equal to 0.1, we have to find out the probability the transmitted code word is decoded correctly. So what is Hamming code? We need not to understand that, right? What if we don't know what is Hamming code, also this problem can be solved. One thing we need to understand is there are 7 bits. This part is required to be understood at 7-4. 7-4 means there's a 4 message bits and 3 parity bits. So finally you are transmitting 7 bits. So the 7 bits what you're transmitting is, let's say D1, D2, D3, D4, D5, D6, D7. If while transmission, if error takes place anywhere, one position, no issue, you can correct it. If no error, no problem. If one error also, no problem. So the finally this problem resolved. It's the probability of correct exception going to happen. If there is no error means out of seven plays, no error is taken place. So seventh is zero. 1 minus epsilon to the power 7, epsilon to the power 0. Okay, no error because error is getting flipped. Next, 1 bit error, 7C1, 1 minus epsilon to the power 6, epsilon to the power 1. Simple. Generally, we have a binomial distribution where we have NCR, P to the power R, Q to the power N minus R. Right? So let us substitute the values. 1 into 1 minus 0.1 to the power 7, 0.1 to the power 0. That's 7 into 1 minus 0.1 to the power 6, 0.1 to the power. On solving this, we should get the answer for the test 0.85. So, the answer. Yes. I hope this is clear. This is basically the finding the probability of at most one bit error. Okay, that will give the probability of exception. Question from communication system, which is related to finding the probability of error when the conditional probability density function of y is given. Two symbols are transmitted, XA or XB, and the output of the channel Y is input to a maximum likelihood detected with zero. The conditional probability density function for Y given XA and XB are who are given. You have to find out the probability of simple error for this. Okay. The maximum likelihood detector means that the probability of symbols XA and XB is same. Okay, then only we can use maximum likelihood detector. Now, in that case, if the probability of symbols are same, the threshold of the detector threshold will be nothing but the point of intersection of two PDFs. Okay. Let me plot the two PDFs first. So, if I want to plot f of y given xa, y going to be something like this. Okay. This is the y. And if I want to plot f of y given xb, y. Now, when you intersect these two PDFs, you are going to get figure. Just by looking at the intersection region now, you will understand what is going to be the solution for this. So let me draw this. I'll draw it to different color. This is the condition which is coming on the detector. Now, where the error is going to take? If you see, the error is going to take place in this region. This is greater than this. Let me just write this. This is f y given xa, and this is f y given xp. If this is greater than this, the error is going to be correct section, right? But here, if this is transmitted and this portion is greater, the error is going to take place between 0, 1, and minus 1. So you can see clearly that if X is transmitted, error is going to take place when the value of y is lying between 0 and 1. So I can write probability of error when X is transmitted is going to be integral 0 to 1, the value of this, okay, this condition. This is e to the power y minus 1. If this one is smaller, sorry, let's take this. E to the power minus y plus 1 beta. Let us solve this. E to the power minus y plus 1 and 0 to 1 become e to the power minus 2, e to the power minus 1. So that is e to the power minus 1, e to the power minus 1. This is the probability of error when x is transmitted. Similarly, probability of error when xb is transmitted, this portion. So this is what will decide that. This is what will decide for this. So this is going to be minus 1 to 0, right? And this loop of this e to the power y minus. This also, when we solve this, we get this as e to the power minus 1, e to the power minus 2. So the average probability of error, PE average, since both the symbols are equivalent, 1 by 2 times of e to the power minus 1, e to the power minus 2, plus 1 by 2 times e to the power minus 1, e to the power minus 2. That's going to become e to the power minus 1, e to the power minus 2. We have to find out the value of this. So it is, I can write 1 upon 2.73 minus 1 upon 2.73 is let me just see this. What is the result? 2.73 0.5. It is going to be 0.366 minus 0.134. Two point three, 0.23. Somewhere near to that, the answer is made for this. Just a calculation, but the process is this. That's the end of question from communication system. Question from communication system. This is, I can say, the most calculation intensive question, and as a suggestion, we should not try such questions in the beginning itself, because they will take time, more calculation intensive, and if you make slight mistakes, the answer could be wrong because options are not given. So let us see what is this question. This question is from the quantization, and the thing that we study in pulse code modulation. There we try to see the quantized value. Consider a real valued source whose samples are independent and identically distributed random variable with probability density function as shown in the figure. Consider a one-bit quantizer that maps positive values to alpha and other values to beta. That means negative values to beta. If alpha star and beta star are the respective choices of alpha and beta that minimize the means for quantization error, Then alpha star minus beta star is equal to how much? So we have to basically find the alpha and beta star. So if we get those values, taking a difference and getting the answer is possible. So let us try to understand. First, try to understand the PDF and what this quantization is actually seeing. So it is telling that when x is lying between 0 and 1, the quantized value is going to be, right, positive values to circle alpha. And when x is lying between -2 and 0, the quantized value is going to be beta. Q is a quantized value. So we do not know what is this quantized value, what is this alpha and beta, we do not know, but we try to find out, we try to choose some value alpha beta so that the error is the difference between the quantization is minimized. Okay, that is it. Now, coming to the PDF. PDF, one property that we know, because this value is not given, I cannot write the equation of this. I need to find out the value of this top portion. So we know that the area under the PDF is equal to 1. So let's say this is K. So since area under PDF is 1, I can write K into 1 plus 1 by 2 into 2 to K whole must be equal to 1. That is 2K is equal to 1, K is equal to 0.5. So this is 0.5. Now I can write the equation of this complete term. I can write the equation of the PDF. Equation will become fx of x is going to be this equation of this line, right? The slope is 1 by 4. So it is 1 by 4x plus 1 by 2 for x line between 0, and it is 0.5 for x line between 0 and 1. That is 0 otherwise. Okay. Now this is some part is done here. Now we have to see if alpha star and beta star are the choices of alpha and beta, then the mean square error. That means I should be able to find what is mentioned in the question is expected value of alpha minus alpha star not this. X minus alpha star minimum mean square estimation, this value to be minimum. Right? Similarly, expected value of x minus beta star whole square should be minimum. Now, if I take this case, expected value of x minus alpha star whole square, it is nothing but equal to integrate this from 0 to 1, because alpha is the choice when it is in when the values are positive. It's going to be Question from communication system. This is, I can say, the most calculation intensive question, and as a suggestion, we should not try the questions in the beginning itself because they will take time, more calculation intensive, and if you make slight mistakes, then answer could be wrong because options are not given. So let us see what is this question. This question is from the quantization, and the thing that we study in pulse code modulation. There we try to see the quantized value. Consider a real valued source whose samples are independent and identically distributed random variable with probability density function as shown in the figure. Consider a one-bit quantizer that maps positive values to alpha and other values to beta, that means negative values to beta. If alpha star and beta star are the respective choices of alpha and beta that minimize the mean square quantization error, then alpha star minus beta star is equal to how much? So we have to basically find the alpha and beta star. So if we get those values, taking a difference and getting the answer is possible. So let us try to understand. First, try to understand the PDF and what this quantization is actually seeing. So it is telling that when x is lying between 0 and 1, the quantized value is going to be right positive values to sample alpha. And when x is lying between -2 and 0, the quantized value is going to be beta. Q is a quantized value. So we do not know what is this quantized value, what is this alpha and beta, we do not know, but we try to find out, we try to choose some value alpha beta so that the error is the difference between the quantization that minimized. Okay, that is it. Now, coming to the PDF. PDF, one property that we know, because this value is not given, I cannot write the equation of this. I need to find out the value of this top portion. So we know that the area under the PDF is equal to 1. So let's say this is K. So since area under PDF is 1, I can write K into 1 plus 1 by 2 into 2 to K whole must be equal to 1. That is 2K is equal to 1, K is equal to 0.5. So this is 0.5. Now I can write the equation of this complete curve. I can write the equation of the PDF. Equation will become fx of x is going to be this equation of this line, right? The slope is 1 by 4. So it is 1 by 4x plus 1 by 2 for x lying between 0 and it is 0.5 for x lying between 0 and 1. That is 0 otherwise. Okay. Now this is some part is done here. Now we have to see if alpha star and beta star are the choices of alpha and beta, then the mean square error, that means I should be able to find what is mentioned in the question is expected value of alpha minus alpha star not this. X minus alpha star minimum mean square estimation, this value to be minimum. Similarly, expected value of x minus beta star whole square should be minimized. Now, if I take this case, expected value of x minus alpha star whole square, it is nothing but equal to integrate this from 0 to 1 because alpha is a choice when it is in when the values are positive. It's going to be 0 to 1 x minus alpha star whole square fx of x dx. Now, fx of x in this case is 0.5. So I can write it as 0 to 1 x minus square 1 by 2. Now we can solve this. We will get this as 1 by 6 x minus alpha cube, right? 0 to 1. And if I put the values, just let me just write that as 1, which is E1. It is going to be 1 by 6, 1 minus cube